Hello America, this is Chris Peralta coming to you live from the studios here in St. Paul, Minnesota. And this is But Should We? Today we have some people coming in to discuss a genetic technology called CRISPR. And no, this isn't something from the new Star Wars movie. This is a technology that our scientists are working to improve to actually change people's genes. CRISPR-Cas9 is a type of germline editing. This means that the technology can change genes in the germline, which are cells that pass on their genetic material to further generations. And when these changes are made, they get passed down to future generations as well. The basics of how CRISPR-Cas9 works is a guide RNA attaches to a specific sequence in the DNA that scientists want to change. When the RNA attaches, a protein called Cas9 approaches and cuts out both strands of the double-stranded DNA, like a pair of scissors. A new strand of DNA then swaps with the cut-out DNA, and there you have it. The amazing thing about this technology is that it can delete, change, or even insert genes anywhere in your DNA. And there you have it, edited DNA. Crazy that we have the technology that can do this. And, as our loyal viewers know, But Should We is all about talking to people like you to learn more about an ethical situation to try to figure out what we should do. Then we bring in an expert in the field to see what their recommendation is. So, let me introduce our guest, Jean Monet.
Well, I'm Jean, and the reason that I'm passionate about CRISPR is because of my son. When he was little, he started displaying symptoms of something that I later found out was called Duchenne muscular dystrophy, or DMD for short. After going to doctor after doctor, they finally recommended that we get him a genetic test. And we found out that he has a mutation in one of his genes that causes something called a frame shift and stops a certain protein from working in his muscles. Watching him grow up and start to lose function was very difficult for his father and I. And now he is wheelchair bound, but it only gets worse from here. I don't know what I'd do. Anyway, my son is the reason I am a strong supporter for CRISPR technology. I would love to come on the show and share more of my story.
Nice to see you today.
Hi Chris, I'm very excited to be here on your segment about CRISPR today.
All right. Now, Jean, as we saw, you're an avid supporter of this technology, is that right?
That's right. I mean, if something could heal your child, I'm sure you would be in support of it too.
I know if my daughter was sick, I would do whatever it took to help her. But not everyone thinks the good of this technology is worth the cost. So let me bring in our next guest, Dr. Ned Eiding.
But, you know, my friends call me Ned. Now, back when I was growing up, I remember hearing about the discovery of this new thing called DNA that they had just discovered. I mean, everyone used to have their parents tell them about how there was something that skipped a generation, or, oh, you have your mother's eyes, or what have you. But that there was actually something that could explain your different traits. Well, that was interesting. It's a part of the reason I wanted to be a doctor. I went through all the school. It was different back then. Of course, I had my own practice for years, and I like to think I saved a few lives in my time. That's part of the reason I find this new CRISPR technology so unsettling. Changing what makes people themselves, I don't know if that saves anyone, not to mention how it can hurt people. So, yeah, Chris, I come on your show and talk about my views on CRISPR.
Thanks for coming all the way out here today, Doctor.
Everyone continue to help people. I gave my daughter my practice a few years back, and I'm glad to keep working to help.
And you mean to help by advocating against CRISPR, is that right?
Absolutely, Chris, and please, Ned is fine.
Now, as you guys know, I'll give you a chance to discuss your views. And we always start with the arguments in favor of whatever ethical topic we are discussing. So we're going to let Jean present her main reason for this technology, if that's all right for you, Ned.
Mm-hmm. So the obvious reason that CRISPR research should continue is that it has the potential to help cure any number of genetic diseases, like DMD.
So there are other genetic diseases that this can help with too?
Yes, things like cystic fibrosis and sickle cell anemia, those are a couple that I've seen research about. CRISPR can even help create mutations that can help prevent non-genetic diseases such as HIV.
It definitely sounds like a benefit, but is this just theoretical? How do we know that would even work?
I'm glad you asked, Chris. For DMD at least, this technology has been tested on mice. There have been positive results on a type of nonsense mutation for DMD, and you may not know what this is,
Sounds like nonsense to me.
but what it is a mutation that makes your genetic code stop from being read altogether, which essentially hides key genetic information.
That sounds serious, Gene.
It is, but the good news is that CRISPR has been able to fix this in these mice. They can either delete the mutation or even repair the mutation to its original state, and they fix this in the germline or sex cells so that these mice pass the fixed DNA onto their offspring rather than the mutation for the disease.
Well, thank you, Gene. It looks like you have your work cut out for yourself, Ned. I wouldn't know how to argue with the saving potential of this technology.
Well, Chris, it's easier than you might think. You have to remember, as you said, and even as Miss Monet brought up again, these alterations are done to the germline. Don't you find it irresponsible to edit something that is passed on to future generations?
I don't know about that. Couldn't it prevent the mutation from being passed down to future generations and possibly eradicate these diseases altogether?
But there are some possible side effects to all these gene editing.
I'll remind you, Ned, you need to have some facts in your argument.
And facts I have, Chris, because even though you can delete certain parts of DNA that could cause a disease, a new one can always arise and potentially be worse. In some clinical trials in humans, the delivery system of CRISPR has even led to death in certain cases.
Sounds serious, Ned.
You betcha. Not only that, but the body's immune responses can ruin gene therapy and pose a health risk to the person receiving that treatment. And antibodies against Cas9 can bind to the enzyme in the bloodstream before it has had a chance to act. And T cells that target Cas9 could destroy cells in which the protein is expressed, wiping out the corrected cells and potentially triggering a dangerous, widespread attack on the body's own tissues.
There are risks that come with every medical procedure, which is why this technology should be used on people who really need it.
Don't they have to test the technology?
They do, and although testing on human subjects can seem very serious and potentially problematic, it's possible for research to be done without actually using the human subjects themselves and to just use human cells to further experimentation. There have been experiments done on non-viable zygotes to get an idea of how humans will respond when certain genes are edited using CRISPR.
Even if we ignore the dangers, and even if human trials are the very last thing, or even mostly unneeded, there is even worse danger.
Oh yeah, that it's saving too many people?
It is the potential of editing more than just diseases. Couldn't this technology potentially change anything about a person, like change their eye color or other physical traits?
Well, I suppose there could be some rules put in place.
What about editing the genes of an unborn baby? What parent wouldn't want the guarantee of a child with no genetic diseases? Or a child with a sex they picked out? Or a pretty eye color? Also, using CRISPR opens the doors to a spectrum of eugenics, which is the racist practice of trying to improve the human race by controlling genetics and reproduction. It can be problematic for future generations with creating new mutations after deleting the previous ones in the offspring.
Now, eugenics is not exactly what is going on here. This isn't trying to change the race or defining characteristics of a group. It's about getting rid of disease. But I agree, you have a point about too much modification in terms of having a perfect child.
Now, regulations may stop the general public from having access to that kind of technology, at least for the moment. But what about the people with a lot of money? Regulations can't stop the rich from getting what they want.
If that was the case, Mr. Iane,
It's doctor.
excuse me?
You called me Mr. just then, but I spent some time getting my MD.
It's clear you think something about me because I have money, but I assure you, I'm not the enemy here. I agree that the modification should be limited to disease. However, if it does come to editing other things, this technology is not the most expensive. That should also be true in the affordability of it for medical purposes as well.
Oh yeah?
That is interesting to hear, Gene.
Well, when compared to other gene editing technologies, CRISPR is already relatively accessible. There are molecular tools that are available in public repositories, and as long as it stays this way, as the technology develops, researchers and companies will continue to make it as cheap and available as possible in a competitive market.
Well, you might just be on to something there, Jean.
And you had some good points too, man.
And I would like to thank you both one more time for coming on the show.
It was lovely to be here, Chris. I think we both learned something.
I'd agree. Thank you, Chris.
Thank you, guys. And finally, I'd like to bring in our guest genetics expert to tell us some more about this technology and where she stands in this argument. My lawyer viewers will know that this person has lended us her skills several times in the past. You might even recognize her from our recent show about organ farming with pigs. Our genetics expert and my personal friend, Dr. Cas9. Nice to see you as always, Cassie. And I know we're all excited to hear about your views on this technology, but why don't you remind us a little bit more about the specifics of this technology?
All right, so I brought in a simple diagram here to help remind the audience of how CRISPR-Cas9 works in summary. The first step is that we use a guide RNA to come in and detect the desired DNA sequence to be edited by the scientists. Once this RNA attaches to the DNA, a protein called Cas9 comes into where that sequence is, and it cuts out both strands of the DNA, kind of like a pair of scissors. After that, the DNA is swapped with another piece of DNA that the scientists edited to make sure that it achieves the desired result. And compared to other technologies, the great thing about CRISPR is that it can specifically control where a gene is edited in the DNA. So there you have it, a summary of CRISPR-Cas9.
Well, folks, I'm sure she did a lot better job than I did explaining the basics of this technology. But now, Cassie, let's answer a couple more questions.
Sounds good, Chris?
Now, my first question I have is, this is all great in theory, but has it been put into practice in any way?
Yeah, so today there is continuing controversy, as we saw previously on the show, in how CRISPR can be applied. Scientists continue to improve their research with CRISPR. In the United States specifically, scientists have successfully used CRISPR to change the DNA of a large number of one-cell human embryos. These embryos were only allowed to develop for a few days, and they were never intended to be implanted in a womb. Although in the United States, Canada, and many other places around the world, specifically in Europe, any sort of germline editing in humans is illegal. The only place where this technology has been used in humans is in China. Currently, the United States has a few legal restrictions for genetic modifications. There is a law forbidding the Food and Drug Administration from reviewing research in which a human embryo is intentionally created or modified to include a heritable genetic modification. There is also a ban on using the National Institute of Health's funding for research using gene editing technologies in human embryos.
Makes a lot of sense, Cassie. And now we've heard from Jean and using her reasoning behind her son with a genetic disease, and we've heard from Ned wanting to keep the medical practice the way it is. But let's hear from an expert. So Cassie, in your professional opinion as a genetics expert, what's your view on this?
So from my personal research done learning about germline editing using CRISPR-Cas9, I conclude that this type of editing can be ethical, as long as it stays within certain borders. I think that this use of genetics should only be used to prevent or cure chronic or life-threatening diseases. However, to be able to come to a place of performing germline editing, the CRISPR method needs to first be perfected, so that the germline editing for preventing disease does not end up causing more harm in generations to come, as many fear. Another roadblock is determining the line of what is a disease worth preventing, versus a disease that is not severe enough to treat or is not always viewed as a disease. For example, many people view the blind or deaf as having a disability. However, other people, mainly within these communities, view these traits not as impairments, but as something that may positively define who they are. Once the ethical committees representing the general public come to a conclusion of what diseases can be prevented using this technology, and once the technology comes to a point where it can successfully prevent disease in a human and their following generations, then this technology can be used to greatly improve people's health, wellness, and longevity. But as you see, we have a long way to go until we reach that mark.
We sure do, Cassie, and I want to thank you again for coming on our show.
Very welcome.
And lending us your very valuable time as a scientist. And, as I'm sure some of your viewers have noticed, she has a nice little rock on her hand today. And I'd like to congratulate you on your engagement, and I wish you a long and happy marriage. Thank you again.
Yep, thank you, Chris.
And all right, there you have it, folks. thank you for coming here and seeing another episode of But Should We? I hope you see you back here next week, and good night, America.